Yesterday we had given a definition for function. We had described what is meant by domain of a function, what is meant by range. We had tried some examples also on finding domain and range. Okay, we will continue that attempt today also. We will consider more functions, maybe slightly more involved functions, and repeat the same exercise of finding the domain, range, and only after finishing or having enough practice over this kind of problems, we will proceed to the next item. Okay. Suppose a function is defined. Now it is not defined by a single formula. I will be using multiple formulae. One formula applies for one part of the domain, and the other formula will be applying for the remaining part of the domain. Say for example 1 plus 2x. This will apply for x less than 4. And another formula I use will be 2x square plus x, and I will make this applicable for x greater than or equal to 4. Simple. I am just avoiding the use of a single formula. What will be f of 0? 1. You have to apply the first line. Okay. What is f of 10? Now you will have to use the second line. 2 into 100 plus 10. Okay. What is f of 4? Second line. What is f of pi? First line. What is f of root 2? First line. Okay. Is the function defined for every x? Yes. So what is the domain? Whole real number system from minus infinity to infinity. Okay. Problem is to find the range. What is the range of this function? Newly defined function. Consider the first part. Applicable only for x less than 4. As long as x is less than 4, can you say something about possible value of 1 plus 2x? Yes, 1 plus 2x also will be less than what? When x is less than 4, 2x will be less than 8, and this whole thing will be less than 9. That means applying this formula, every value that is less than 9 is obtainable as function value. For which value of x that value will be obtaining, not interested, we are not interested in that. What values are obtainable as function values? All values or all real values which are less than 9 are obtainable using this formula. A part of the range will be from minus infinity to 9, 9 excluded. Agreed? Only a part. Okay. Remaining part will be obtained using this part of the definition of the function. This part is applicable for x greater than or equal to 4. The formula we are using 2x square plus x. What values will be attained by this function when x satisfies the condition x greater than or equal to 4? This is what we are required to determine. Simplest method, this I was trying yesterday also, use the graphical representation of this. A quadratic with x square coefficient positive will have as graph a parabola with vertex below. If x square coefficient is negative, reverse. X square coefficient positive, this way, come. Okay. This will be the vertex for the parabola. Now for the moment you do not consider this, ignore this. This we will take care of only later. For the moment you just concentrate on this quadratic expression. Let us draw the graph for this expression, thinking that x can take any real value from minus infinity to infinity. Then unwanted portion will be removed, that will be done later. Okay. This parabola will have as vertex this point the point with the x coordinate minus b by 2a minus 1 by 4. When x is minus 1 by 4, the y coordinate will be, apply the value minus 1 by 4 in this, 2 into 1 by 16 minus 1 by 4, 1 by 8 minus 1 by 4, minus 1 by 8. Knowing the sizes and the signs of the coordinates, we are now in a position to mark the coordinate axis. The x coordinate is negative, means the y axis is to this side. Agree? Y coordinate is negative, means x axis is above. Somewhere here is the y axis, somewhere here is the x axis. Certainly, is origin a point on the graph? Yes, is satisfied by x equals 0, y equals 0. Let me make this point lie on the graph. Okay. Roughly, these are the positions of the axis, and that is the graph of the function. But the formula, the part 2x square plus x in the definition of the function is applicable only for these values of x. This is not applicable for an arbitrary x. You cannot use x equal to 0 at the point x equal to 0, you cannot use this formula. At the point x equal to 2, you cannot use this formula. Your application of the formula starts only after x equal to 4, including x equal to 4. Where does x equal to 4 lie on this x axis? This is origin. X equal to 4 is somewhere here. To the left of x equal to 4, this formula is not applicable. Formula is applicable only on the right of x equal to 4. Only this portion you need include. Okay? What values are attained by this part of the graph? All values greater than or equal to the y coordinate of this point. What is y coordinate of this point? This point corresponds to x equal to 4. At x equal to 4, what is the y coordinate? 36. 36 onwards up to infinity, any value is attainable by our function. So, range becomes this union, one more interval starting with 36 ending at infinity, not reachable. What about this point? To be included? Not included. To be included is the range of the function. Okay. I am not getting my function defined for every real value of x. No need that whenever you get a function, it should be defined for every real value. There is no need. This function is not defined for all values of x. It is defined by this formula for x belonging to this interval, this formula for x belonging to this interval. For other values of x, I am not bothered. I am not defining the function at all. What will be the domain for the function? At which points is my function defined? Before copying these intervals, just check throughout this interval, is this expression obtainable? Have a cross check. Suppose this is undefined at 1 or 2 points of the interval, then you will have to keep those points outside. Even though in the definition I mentioned that this is applicable for every x here, suppose it is not possible to evaluate this at x equal to some one of the points or some few points belonging to the interval, you will have to keep those points out. Is this well defined for every x in this interval? Yes, no problem. For every x in the interval, this will be a positive expression, and therefore finding the square root will be possible. Okay. What about this? Is this also meaningful throughout this interval? Yes. In order to have this meaningful, x plus 1 must be a strictly positive number. Otherwise, you will not be able to find the square root, and to have the ratio meaningful, denominator must not be equal to 0. So, requirement is x plus 1 must be greater than 0 is satisfied for every x belonging to the interval. Therefore, the domain will be the entire set over which I have defined my function. Agreeable? What is the range? Next question. Let us examine. Let us find what values are attained by this function when x takes various values from 0 to 1. What values are attained by this formula when x varies from 2 to 3. First, this one. Usual approach, my approach, graphical approach. Ignore the radical sign. Simply consider the quadratic. Draw the graph of the function under the radical sign there, x square plus x minus x square plus x plus 1. Because it is a quadratic with x square coefficient positive, graph will be a parabola with vertex below. The vertex will have x coordinate minus b by 2a. When x is minus half, y will be, I am just considering x square plus x plus 1, ignoring the radical sign, just x square plus x plus 1. Okay. When x is minus half, x square plus x plus 1 will be 1 by 4 minus half plus 1, 3 by 4. What are the positions of the coordinate axis? Y axis is at the right, x axis is below. Agreeable? Yes. Something like this. This height is 3 by 4. This distance is half. Okay. If x square plus x plus 1, one second. Okay, this is the graph of x square plus x plus 1 defined for all real numbers for x from minus infinity to infinity. In our case, the formula, of course, with radical sign, let me take care of the radical sign at the end. Our formula, this part of the formula applies only for x between 0 and 1. Let us see what portion of the graph represents the interval corresponding to, or represent the part of the graph corresponding to interval 0 to 1. This is 0, somewhere here is 1. What is the portion of the graph covering the interval 0 to 1. Above 0, you have one point of the graph. The point having coordinates, apply x equal to 0, 0, 1. This will be the starting point of the segment corresponding to the interval 0 to 1. Then the ending point, it has x coordinate 1, apply x equal to 1, you get y coordinate 3, the point will have coordinates 1 and 1, 3. This segment is the segment lying over the interval 0 to 1. The graph of x square plus x plus 1 corresponding to the interval will be this segment. I am required to obtain not x square plus x plus 1, instead the square root of x square plus x plus 1. Do you find throughout the interval the function is strictly increasing? Yes. So, the values will be numbers between 1 and 3. These are the values of x square plus x plus 1. These are numbers between 1 and 3. So, what will be the values of root x square plus x plus 1 for x corresponding to the interval 0 to 1? X square plus x plus 1 lies between 1 and 3. So, root of x square plus x plus 1 will lie between root 1 and root 3, 1 and root 3. Agree? One portion of the range is interval 1 to root 3. Formula is not applicable at 0, not applicable at 1. So, none of the endpoints will be included. Interval will be strictly open interval. One portion. Coming to this part. What values are attained by 1 by root of x plus 1 as x varies from 2 to 3? Yes, it is very simple now. The expression we are having under the radical sign is not quadratic, simple linear. And this linear function x plus 1 starts at the value at the point x equal to 2, attains the value 3, starts at 3 and ends at 4. X plus 1 takes the values between 3 and 4 as x varies from 2 to 3. Agree? Therefore, root of x plus 1 will vary from root 3, start from root 3 and end at root 4, that is 2. When you apply reciprocal, what will happen? Your x is varying from 2 to 3. X plus 1 is varying from 3 to 4. Root of x plus 1 will be varying from root 3 to 2. When you apply reciprocals, 1 by root 3, values will lie between 1 by root 3 and 1 by 2. Which of them is smaller? 1 by 2. Left end point of the interval 1 by 2, right end point 1 by root 3. Interval will not be from 1 by root 3 to 2, 1 by root 3 to 1 by 2, instead will be from half to 1 by root 3. Okay? Values will be traced in the opposite direction. That's all. So, interval is starting point of the interval 1 by 2 to 1 by root 3. Are the end points to be included? Yes. Okay, enough on this type. Next, I go back to single formula definition used to define a function. I will consider one more function which is defined by a single formula, but the formula that I am going to use will be slightly more complicated than the ones we were using yesterday. Did we try a function of the form ax plus b yesterday? Yes. Did we try a reciprocal of this also in yesterday's class? Yes. What about square root of this? We have tried. Reciprocal of the square root also has been tried. Quadratic we have. Root of a quadratic we have done. Reciprocal of quadratic also done. Reciprocal of root of quadratic also tried. Even today we tried that. Okay. What more complication you can expect now? We will consider a fraction in which none of the numerator or denominator will be a constant. Instead, both will be variables. To begin with, let the numerator will be a linear, denominator be a quadratic. Some linear, some quadratic. No restriction on the domain. You are free to determine what the domain is. No restriction on x. So, I am not giving any instructions regarding the interval on which the function is defined. You have to determine the set of all x on which you can apply this formula and define that to be, accept that to be the domain of the function. Okay. Both domain and range are to be determined. What are the points at which you can apply this formula? you are having a rational function. The possible point where a rational function may be undefined is a point where the denominator is 0. At no other point we have any difficulty in computing the value of the expression. Difficulty arises only when denominator is 0. Can this denominator be 0? Can this x square plus x plus 1 be 0? Does there exist a x such that denominator is 0? No. How do you know that? Discriminant is positive, means the expression is throughout positive. Am I right? I don't know. Who told discriminant is positive? Me. You accepted it? What is the discriminant? Negative. Because the discriminant is negative, it is throughout positive. It has no real roots. Only when there are real roots, a part of the graph lies below, another part lies above. And there will be points where the expression vanishes. I think my argument is okay. Yes. When the, yes. Provided A is, no, I didn't mention which part lies above, which part lies below. Okay. You can have the reverse parabola also. This does not vanish because x square plus x plus 1 equal to 0 have non-real roots. There do not exist real numbers such that x square plus x plus 1 equal to 0. How do you know that there do not exist such numbers? By finding the discriminant, observing that the discriminant is a negative number. So, denominator is never 0. About numerator there is no problem, is a linear expression always determinable. Therefore, the domain becomes the entire set of real numbers from minus infinity to infinity. Suppose this is the denominator, will there be any change in the domain of the function? At what point does the denominator vanish? Does there exist a x such that x square plus x minus 1 equal to 0? What is the discriminant now? What is the value of the discriminant? Root 5 is a strictly positive number. Does the equation have real roots? Yes. Will there be two numbers such that the expression is equal to 0? What are those numbers at which the denominator vanishes? Minus b plus or minus root of b square minus 4ac 5 divided by 2a. These will be the 2 points where the denominator vanishes. At these 2 points the expression will be undefined. These 2 points will have to be kept outside from the set of real numbers. What remains will become the domain of the function. Okay? R minus these 2 points. If you want the domain to be described as union of intervals, minus infinity to smaller of the numbers, open interval, union, from smaller of the numbers to the larger of the numbers, again open interval, union, larger of the numbers to infinity, again open interval. Agreed? Union of 3 intervals, one of them finite, 2 infinite. Okay. What about this? Will the denominator vanish at any point? Yes. There exist points where the denominator vanishes because the discriminant is positive now also. I don't know. Yes. The points where the denominator vanishes will be minus 3 plus or minus root. Okay. Again, domain will be set of all real numbers with the these two particular points removed. Okay. Now the situation has got slightly more complicated. The function will be undefined not only at a point where the denominator vanishes, but also at a point where this expression is not evaluable. A root of an expression cannot be always determined. This is obtainable only when the expression under the radical sign remains positive or non-negative. But to have, we are having the expression in the denominator, so we will need it to be non-zero also. So requirement becomes x square plus x must be strictly greater than 0. Agreed? Yes. Is this x square plus x strictly greater than 0 for every x? No. No, it does not remain positive throughout. Actually, x square plus x, this quadratic has two real roots, and those real roots are -1 and 0. Right, I think. Yes. Because this is a quadratic with x square coefficient positive, for every x between the roots, this will be, what happens? When a quadratic has x square coefficient positive and the quadratic has two real roots alpha and beta, for every x between the roots, the sign of the expression will be negative, and for x outside the roots, the sign of the expression will be positive. If x square coefficient is negative, opposite will take place. For x in between you get positive, for x outside negative at the points 0. Now, x square coefficient positive, these are the roots. For x outside, expression is positive. For x between, expression is negative. Square root is obtainable for x outside, square root not obtainable for x inside. Domain will become the exterior of this interval. -infinity to -1, open, union, 0 to infinity, again open. Agreed? Domain, only domain I am referring to. Okay. Let me go back to my original problem. I need to find the range of this. I have noticed that the domain is the set of all real numbers. I need to obtain the range of the function now. Any idea? Domain has already been obtained. Domain has been obtained as the entire set of real numbers from -infinity to +infinity. Now, how to obtain the range? Numerator is not a constant. If the numerator were a constant, I would have tried drawing a rough sketch of the graph of x square plus x plus 1, finding out what values x square plus x plus 1 can take. In using those values, that set, determining what values are taken by the reciprocal, and thus identify the range of the function. If you had a constant in numerator, then also process would have been very simple. Simply draw the graph. Actually, no need to draw the graph. You know the graph is a straight line extending from -infinity to +infinity. You could easily conclude that range must be -infinity to infinity. If the denominator is a constant, numerator is that linear polynomial. Now, difficulty, in both places we have variables. Even numerator is a variable, denominator is a variable. When denominator attains a particular value, numerator attains a corresponding particular value. When denominator is say 3, when x equal to 1, denominator is 3, numerator also will be becoming 3. It cannot take any other value. When denominator takes a particular value, you have to determine for what value of x that value is attained, and you have to apply only that value in numerator, determine the value of the numerator. So, some difficulty is there. What to do? Our method will be just to call the function value y. You are sure that this denominator is not 0. Simply cross multiply, obtain this as a quadratic equation in x. Agreeable? Cross multiply, rearranging the terms, I am obtaining a quadratic. I have already determined the domain. I have found that the domain is the entire set of real numbers. So, x is free to take any real value. This is a quadratic. is a quadratic in unknown x. So, what will be the roots of this equation? X values. What are admissible x values? Arbitrary real values. What does this mean? Roots of this equation are always real. Never you get this as a quadratic with non-real roots. Never you get this as an equation with imaginary roots. Agree? You assign any value for x, you will get a quadratic equation here. Roots of that equation will be two real numbers. Agree? When does a quadratic possess real roots? When the discriminant is greater than or equal to 0. What is the discriminant? Yes. On simplifying, y square minus 4y square minus 3y square. Let me shift it to the other side. Minus 4y minus of minus 4y. Cancel. Plus 4. Okay. Y square is less than or equal to 4 by 3. When does y square be less than or equal to 4 by 3? For what values of y you get y square less than or equal to 4 by 3? When y lies between square root, negative square root of 4 by 3 and positive square root of 4 by 3. So, y must belong to the interval minus 2 by root 3 to plus 2 by root 3, with end points to be included or excluded. This is the set of all possible values of y. This is the range for the function. You assign any value for x in this formula, the value you get for f of x will be some number belonging to this interval. Okay. Shall we complicate the situation still for a little more? Replace the numerator by another quadratic. Okay. Again, denominator is a quadratic never becoming 0. Domain is the entire set of reals. Problem is to determine the range. Our same previous method works. Agreeable? You got a quadratic in x. Roots are values of x, but you have already found x can take any real value. So, this is a quadratic whose roots will be always real. Roots are always real means discriminant is always non-negative. Apply the rule. Simplify. Y square 4y square minus 2y, and here how many y's you get? Minus 20y. Minus 20y, this minus 2y shifted to that side, right? Correct unta? Yes. Constant term 1, and on this side I am getting 4 into 2 into 3, 24 plus 24. If 1 is shifted to that side, 23. So, the condition on y, the condition which always will be satisfied by y is 3y square minus 18y plus 23 less than or equal to 0. Okay. Observe that this is a quadratic with y square coefficient positive. A quadratic with y square coefficient positive, when will it be negative? A quadratic with the leading coefficient positive becomes negative when x lies, or the variable, in this case variable is y lies between or outside. I am asking for ax square plus bx plus c, a positive. I am asking when is this expression negative, when is this expression positive. This expression will be negative when x lies between the roots or outside the roots? Between the roots. Because graph will be something like this. You want this to be negative. If the position of the x-axis is like this, for x between these values, y coordinate is negative. For x outside, y coordinate is positive. If the graph is like this, for x between, y will be positive. For x outside, y will be negative. Agree? So, this is negative if, or non-positive if y lies between the roots. What are the roots? Minus b, smaller root, minus root of b square minus 4ac. Is it going to be a negative number? Let me write down first. What is 18 square? 324. Minus 12 into 23. 276. Fine. Divided by 2a. 6. The other root is 18 plus root of divided by 6. Y must lie between these two. Let me simplify. 3 minus how much? 48. 48 means 4 root 3. Yes, 4 root 3 by 6. The other root is, am I right? Our y will lie between these two. Are the endpoints included? Yes. This is the range for our function. Apply any value for x, the value that the function attains will be some number belonging to this interval. Also conversely, every number belonging to the interval is attainable by the function. There will be a x value for which function value is one of the numbers belonging to this interval. Next, let me consider some trigonometric functions. I am told you have already become experts in trigonometry. You know how to deal with any kind of problem on trigonometric functions. We will have only very simple problems here, problems of finding domain and range. Domain is for what numbers you can find sin x, any number. Range, what values are attained by sin x? Closed or open or semi-closed end? Okay. Yes, tan is not defined at every point. There are certain points where tan remains undefined. Your tan, one of the properties says tan x is sin x by cos x. Denominator cos x is not a function which always takes non-zero values. Cos x can vanish. There are points where cos x becomes 0. At those points, your tan x remains undefined. What are those points? Those points will have to be kept outside the domain. What are the points where tan x, when tan x is undefined, cos x is 0? Pi by 2, 1 point. 3 pi by 2, another point. List all the points. N pi by 2. So 2 pi by 2 also is a point. 2n plus 1 pi by 2. What value n can take? Any natural number, cannot be a negative integer. N cannot be minus 1. When n is minus 1, what is 2n plus 1 pi by 2? Minus pi by 2. Is not cos x 0 at minus pi by 2? Yes, you have to keep that point also out, away. What are the points to be kept outside? All points of the form 2n plus 1 pi by 2, where n can be any integer. This will be the domain. Can you describe it as an interval or union of intervals? It will not be a single interval, but may be expressed as a union of intervals. What will be that union? Any attempt? Yes? Not possible? Yes, yes. What are the intervals that you will be getting? Mention, list some of the intervals belonging to our domain. Pi by 2 is not there, but points to the right of pi by 2 may belong to the interval. From pi by 2 to what point I can go up to? 3 pi by 2. Both endpoints not to be included. This will be one of the intervals belonging to the domain. Next interval belonging to the domain will be, it will start from 3 pi by 2. 3 pi by 2 to be excluded. It will go up to 5 pi by 2. Next interval starts at 5 pi by 2, goes up to 7 pi by 2. Can you give a general representation for this interval? Consider any of the intervals. What is its left end point? It's a multiple of pi by 2. What kind of multiple of pi by 2? Do you have all multiples of pi by 2 here? No. You have only odd multiples of pi by 2. Okay. Next end point of the interval starting at 2n plus 1 pi by 2 will be, interval length is pi, therefore 2n plus 3 pi by 2 will be the end point of the interval. This is a representative interval belonging to my domain. I have to consider all possible open intervals of this type, where n ranges over set of integers. Is the domain of my function. Okay. List all intervals of this form, take the union, what you get will be the domain. It will be an infinite union, not a finite union. There are infinite number of sets to be, intervals to be written, and then their union to be taken. Okay, domain is that. What about the range? Tan x range. Minus infinity to infinity, any value it can take. Fine, good. Okay. Secant x. Is secant x defined very well? This same set, is it not? For what reason this became the domain of tan x? Tan x is sin x by cos x. To have tan x meaningful, cos x must not be equal to 0. So what we found here is the set of all points where cos x is not vanishing. Same will work as domain for secant also. Okay. And range. Now it will not be R. It will not be from minus infinity to infinity. Not every number from minus infinity to infinity can be attained by secant x. It takes only those values which lie numbers outside the interior of minus 1 to 1. Okay. You know the meaning of mod? Yes. No change. There will be a change. Will there be any change? No. This will remain as it is. The points where mod tan x is meaningful, defined, will be the same. This will change now. This will become, you are applying modulus. Negative values do not appear now. Okay. No change. Okay? Yes. Yes. I want root of sin x to be obtainable. Is root sin x always obtainable? No. In order that this may be obtainable, sin x must be greater than or equal to 0. When do you get sin x non-negative? In the first quadrant, for numbers between 0 and pi by 2, sin x is positive. For numbers between pi by 2 and pi, you get non-negative. For numbers between pi and 3 pi by 2, negative. 3 pi by 2, 2 pi, negative. Again from 2 pi to 2 pi plus pi by 2, positive. Okay, what is the domain? One interval in which sin x is positive is from, or non-negative, is from 0 to pi. Another interval in which sin x is non-negative is from 2 pi to 3 pi. I have included the endpoints. I hope there is no objection to this. Okay. One more interval where sin x remains non-negative is 4 pi to 5 pi. On this side also you have intervals where sin x is non-negative. Minus pi to minus 2 pi to interval length can be only pi, not 2 pi. Minus 2 pi. Minus 2 pi means this. Agree? This is minus 2 pi. Okay, minus 2 pi to minus pi. Which of the two numbers, minus 2 pi and minus pi, is smaller? Minus 2 pi is smaller. So, left hand point of the interval is minus 2 pi. Right hand point minus pi. Okay, the interval preceding this. Okay. Give a general representation for these intervals. Left hand point is always an even multiple of pi. Agree? Not n pi. 2n pi. 2. Interval length is pi. The right hand point will be pi added to this left hand point. Infinite union, where n ranges over the set of integers, okay, will be the domain for the function. What about the range? What are the values that this sin x can take? Minus 1 to 1. But for sin x between minus 1 and 0, square root is not obtainable. Those points have been left outside the domain. The only values retained are the values points where sin x takes values from 0 to 1. When you apply square root, 0 to 1 will be the range, and this will be the domain. Okay, cosecant x need not discuss because secant has already been discussed. Okay. Domain. R, all real numbers. Range. This attains values from -1 to 1, add 3 to it, root 2 to. Are both endpoints attainable? Okay. No, my question is, what is the domain? Null set. If domain is null, range also has to be null. No thinking needed. Domain. R. Yes, yes. When does this become 0? Give me name one point, at least one point where this vanishes. 1 to root 2. Sin square x will lie between 0 and 1. When you add 1 to it, the sum will lie between 1 and 2. Square root lies between 1 and root 2. To have the expression meaningful, denominator must not be 0, denominator must be meaningful. Denominator will become 0 when sin x and 1 are equal, sin x is equal to 1. What are the points where sin x is equal to 1? Only plus 1, minus 1 is not to be accepted. Pi by 2? At 3 pi by 2 is sin x 1? Minus 1 is okay for me, 1 minus minus 1 will not be 0. 5 pi by 2, 9 pi by 2, general representation. Two n plus 1 pi by 2. 2n plus 3 pi by 2. For n equal to 1, it is this. For n equal to what, it will be this. 3. In between there is one missing value. N equal to 2. For n equal to 2, what is 2n plus 3 pi by 2? Is it a point belonging to this set? No. 4n plus 1 pi by 2. This is one set of points to be removed from. I do not know whether there are more points to be removed. So, my answer is not yet finished. One set of points to be removed are 4n plus 1 pi by 2, n belonging to z. These are the points where the denominator becomes 0. One more set may be there. What is the set of points where this root is not obtainable. Root is not obtainable if 1 minus sin x becomes negative. Is there any point where 1 minus sin x becomes negative? Sin x always lies between minus 1 and 1. So, 1 minus sin x will be lying between 0 and 2, is it not? The points where this becomes 0 have already been removed. For other values, there is no problem in determining the square root, in determining the function value also. Okay? Whatever has to be removed has been removed. What remains is the domain of the function. Can be described as an infinite union. Let me leave it like this only. Next, what is the range? Range. Sin x takes a value between minus 1 and 1. Now, in this case, 1 excluded. 1 we have excluded. Okay. So, 1 minus sin x takes a value between 0 and 2, 0 excluded. We have removed the points where this becomes 0. So, square root of the expression takes a value from 0 to root 2, 0 excluded. Reciprocal 1 by root 2 to this denominator is taking values between 0 and 1, 0 and root 2, 0 excluded. Reciprocal will take values between 1 by root 2 to infinity. Next, f of x equal to 2 sin x plus 3 cos x plus 1. So far we were dealing with expressions involving a single function. Let me include two functions now. It is a combination of sin and cos, 2 sin x plus 3 cos x plus 1, at which points the function is undefined, at which points you can apply the formula, obtain a value for the function. All real numbers. Domain over. Simple enough. Next question is to determine the range. What values are attained by this function? What values are not attainable by this function? This takes values between minus 1, 1. This takes values between minus 1, 1. Shall I argue that this will be between minus 2 and 2? This will be between minus 3 and 3. Therefore, the sum will be between minus 5 and plus 5, plus 1. The sum will be between minus 4 and 6. Will you accept this argument? No, not acceptable. Why? When sin x becomes 1, cos x will not become 1. It will become 0. When sin x is 0, cos x will become 1. So, corresponding values are different. You cannot simply add the intervals and claim that the sum of the endpoints give rise to the range of the function. Some other approach you will have to follow. What is the range of the function? How to obtain it? The difficulty is in the presence of varieties of functions. Suppose you had just one function here, it would not have been a problem to determine the range. It would have been a very simple exercise. Suppose this is not there, it is a very simple exercise. Because of the appearance of multiple functions, functions of different kind appearing simultaneously, the problem has arisen. We have come across this difficulty. How to get rid of this problem? Is there any way to combine these two? Right. divide and multiply by root 13. Our expression was an expression of the form a sin x plus b cos x. We simply divided and multiplied it by root a square plus b square. What is the advantage? As coefficient of sin x, I have got a number which in numerical value is less than 1. As coefficient of cos x, I have got another number whose numerical value is less than 1. One more point, suppose you square this and add the two squares, the sum you get will be 1. Agree? That means because this is less than 1, there exists a alpha such that this is equal to sin alpha. Because this square plus this square is 1, for the same alpha for which this is sin, this will be cos alpha. Or I can even make this cos alpha and this sin alpha. Simultaneously this will happen. Because sum of the squares of the numbers is 1, the alpha for which this is sin alpha will be equal to the beta for which this is cos beta. Okay, using that idea, I find this as, let me make this sin alpha. Sin x sin alpha plus cos x cos alpha is cos a cos b plus sin a sin b is a is x, b is not known. I am known, but I am not writing it as it is. I will give the description separately. Where what is this alpha? Is the angle such that, or the number such that the sin ratio is 2 by root 13 and cos ratio is 3 by root 13, or clubbing the two, tan ratio is 2 by 3. But there are many angles with tan ratio equal to 2 by 3. Are you free to use any of those values as value of alpha? No. You want sin to be positive, cos to be positive. In which quadrant do you get both sin and cos positive? So choose the first quadrant angle for which tan is 2 by 3. Even in third quadrant tan is positive. Do not select that angle belonging to third quadrant. Choose the first quadrant angle for which tan is 2 by 3. That alpha has been used here. The expression takes this form. Okay. The function formula is equal to this. Therefore, what is its range? Now it must be a simple exercise for you to determine the range, because the complication which was present earlier in the formula has been avoided. This is a number between minus 1, 1. This will be between minus root 13 and plus root 13 plus 1. Add. Are both endpoints reachable? Yes. Is the range. Agreed? Some simpler exercises. Immediately, without making any calculation, you can tell me what the domain is, what the range is. Domain R, minus infinity to infinity, no problem. Range. Now also you are having two functions, both sin and cos are appearing, but in a different way. Okay, because sin x cos x is expressible as, this takes values from minus 1 to 1. So this will take values from minus half to plus half. Add 1 to that, you will get the size of the range or endpoints of the interval determining the range. Okay. some reduction needed in order to obtain to get an idea about the range. Reduction needed is, yes, agree? Yes. What is sin square 2x? I want to get the degree further reduced. I want to get the degree as 1. I want a linear expression in place of that. Or shall we keep it as it is? I think even with the present form I can determine the range, no problem. Okay, this is further reduction not needed. Sin square 2x is a number between 0 and 1. 1/4 of that will lie between 0 and 1. Add 1 to it, you get the endpoints of the range. Am I right? So, endpoints will be 1 and 5/4. Closed interval 1 to 5/4. Okay. Yes. Agreeable? Yes. Oh, no need, no need. We can retain it. Yes, yes. What is the interval? 1 to 17/16. Fine. At least domain you can immediately predict. R minus infinity to infinity. How to determine the range next? Forget the presence of cos x. Simply imagine it to be the function 2y square minus 3y plus 1. What values will this take? Let us draw the graph. It's a quadratic with y square coefficient positive. So, graph must be a parabola with vertex below. X coordinate of this vertex minus b by 2a, 3/4. Y coordinate 2 into 9/16 minus 3 into 3/4 plus 1. Two into 9/16 is 9/8. 9/8 minus 9/4. 9/4 is 18/8. 9/8 minus 18/8 minus plus 1 minus 1/8. Okay. This means 2y square minus 3y plus 1 attains all values above this level. It takes every value greater than or equal to minus 1/8, provided you are allowed to take y any value from minus infinity to infinity. If y is allowed to take any value from minus infinity to infinity, this expression will take values greater than or equal to minus 1/8. But in our case, we are having this. We are having 2y square minus 3y plus 1, where y is cos x. Does cos x take any value from minus infinity to infinity? No. It takes only those values from minus 1 to 1. Let me mark the x and y axis. X axis is on which side? This side. Sorry, y axis is on this side and x axis is above. Okay, something like this. what is that my requirement? Cos x is attaining values from minus 1 to 1. Okay, from minus 1 to, this is 3 by 4, 1, maybe I do not know the exact position. When y ranges from minus 1 to 1, what values are attained by 2y square minus 3y plus 1? That is our question now. Do you find from this interval to this interval, the function is partially decreasing and then increasing? Yes. Therefore, the least value attained is minus 1 by 8. 3 by 4 is the x coordinate. Least value is this depth is minus 1 by 8. Agreeable? And highest value is either the y coordinate of the point at x equal to minus 1 or the y coordinate of the point at x equal to plus 1. Agree? My figure shows that this coordinate will be less than the y coordinate here, but let me make explicit calculations. The figure that I have drawn is not according to scale. There may be some mistake due to misuse of the scale in my figure. So, let me make the calculations. At y equal to 1, what is the value? 0. I have not drawn the figure properly. This is the point y corresponding to y equal to 1. At, sorry, this is minus 1. At y equal to minus 1. Yes? 6. Okay. No problem. At y equal to 1, 0. So, which is the highest value attained by my function? 6. Least value minus 1 by 8. Range minus 1 by 8 to 6. Are both the endpoints to be included? Can cos x be minus 1? Yes. Can cos x be plus 1? Yes. Both endpoints to be included. It will be a closed interval with the endpoints minus 1 by 8 and 6. Agreed? Okay, then. We have to find domain as well as range. In order to get the domain, I need ascertain what are the points at which this is not negative. This must be greater than or equal to 0. Okay, first let me convert this into an expression involving a single variety of trigonometric functions. There are both sine and cos. Let me make it a function involving only one variety. Yes. 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 Now, to know when is this expression non-negative, greater than or equal to 0. Okay, one argument may be apply the method of completing squares. First, I will make this coefficient 1. Then try to obtain these two as two of the terms in the expansion of a perfect square. What do I get on expanding this? Minus cos square x as desired. Then double product 2 into cos x into minus 1 by 4 is half cos x, its negative is as desired plus half cos x. The constant term I obtain 1 by 16 with a negative sign, but my requirement is 3 by 2 or 24 by 16. 25 by 16. To have this expression greater than or equal to 0, I will require this expression to be less than or equal to 25 by 16. The question now is, when is this less than or equal to 25 by 16? To have cos x minus 1 by 4 whole square less than or equal to 25 by 16, my requirement will be cos x minus 1 by 4 must be a number between minus 5 by 4 and plus 5 by 4. For this, I will need cos x to be a number between minus 1 and 3 by 2. Is this always a number between minus 1 and 3 by 2? Is cos x without any restriction, does it take a value between minus 1 and 3 by 2? Yes, it is a number between not only minus 1 and 3 by 2, it is well within that interval, it is between minus 1 and 1. You are actually permitted to go up to 3 by 2, it is not going up to 3 by 2, it is stopping at 1 itself. So, we are more on the safer side. The expression always remains greater than or equal to 0, square root is always defined, domain is the entire set of real numbers from minus infinity to infinity. How to obtain the range? Again, this form may help you in the determination of the range. For any x, given x, this takes a value from minus 1 to 1. Because this takes a value from minus 1 to 1, this will take a value from minus 5 by 4 to 3 by 4. The square number inside parenthesis is taking a value from minus 5 by 4 to 3 by 4. The square will take a value from a variable x is taking values between 0 and 2. The square will take values between 0 and 4. A variable is taking values between minus 2 and 0. The square will take values between 0 and 4. A variable is taking values between minus 1 and plus 1. Square will take values between 1 and 1. Zero and 1. A variable is taking values between minus 2 and 1. Square will take values between 0 and 4. Okay. This is taking values between minus 5 by 4 and 3 by 4. Square will take values between 0 and 25 by 16. Therefore, this difference will take values between 0 and 25 by 16. Square root will take values between into root 2 takes values between, and that is your range. You have obtained the answer. I think that much is enough for today. I will continue when we meet next.